Doms, can you check if this is already in the center?
Well, it looks alright, but I'm not sure.
I need to get this exactly at the center because I will use it as a guide for centering the cutouts as well.
The stage is too wide to use a meter stick.
Hi there, guys.
Oh,
Hi, Jay.
How are you doing with the decorations?
Well, I want to make sure that I hang the logo exactly at the center. But we can't find a way to locate the center of the stage wall.
I think I have an idea.
Good.
Do you have a piece of string?
I have a ball of yarn here. Will this do?
That will do just fine. How high would you like the logo to be?
Just above your head.
Okay. Put the other end there and I'll put it here. Then let's join the two ends.
Okay.
There, that's where the center lies.
Wow, that was quick. How'd you figure that out?
Oh, I just remembered what we learned in our geometry class. Okay guys, see you later for the induction ceremonies. I need to check the registration table.
Okay, see you and thanks, Jay.
Bye!
That was quick thinking on the part of Jay. With the use of yarn, you figured out quickly the center of the stage.
Yes, Miss Michelle, Jay's idea was very smart.
Oh yes, simple and smart idea. Today we will study how we can be smart too.
Are we putting up another backdrop again?
No, Doms, I only meant that we will also discuss how we can find the center, not of a wall, but of any line segment joining two given points.
You mean the midpoint of a line segment?
Yes, we learned some things about the midpoint in our previous lesson. Can you recall what the midpoint of a line segment is?
I think it is the point that divides the segment into two equal parts.
Yes, that's right. We will assume that we are given the coordinates of the two endpoints, say A with coordinates x1, y1 and B with coordinates x2, y2. We'll also denote the midpoint by M with coordinates x and y. Now I will draw horizontal and vertical line segments to form the right triangles AMP and MBR. Can you tell me the coordinates of the points P and R?
Let me see. A and B lie on the same horizontal line, so they must have the same y coordinate.
So M and P also have the same x coordinate since they lie on the same vertical line.
Then P has coordinates x and y sub 1.
Similarly, the coordinates of R are x sub 2y.
Can you tell me which parts of the two triangles are congruent and why?
Since M is the midpoint of line segment AB, we have AM congruent to MP.
Angle APM is congruent to angle MRB, since both are right angles.
If we extend line segments AP and MR into lines, then these two lines are both parallel, and line AB is a transversal. So angles MAP and BMR are corresponding angles and must be congruent.
How do you know that they are parallel?
It's because they are both horizontal.
Oh, so that means MP and BR are parallel too. Then that means angles AMP and MBR are congruent as well, right?
Well done! I'm glad you still remember what you learned about parallel lines and transversals. Can anyone tell me what relationship exists between our two right triangles?
Two pairs of corresponding angles are congruent, and the sides included between these angles are also congruent. Then the two triangles are congruent by ASA.
That's right. Now which sides of the two triangles are congruent?
AP and MR are congruent, and so are MP and BR.
Can anyone tell me the lengths of these line segments?
Since AP is horizontal, the length is just the difference between the x coordinates of A and P. We have absolute value of AP is equal to x minus x sub 1.
How about the length of MR?
It is also the difference of the x coordinates. We have absolute value of MR is equal to x sub 2 minus x.
Miss Michelle, can we also write this as x minus x sub 2.
Class, what do you think?
Since x is less than x sub 2, x minus x sub 2 will be negative. So we can't do that. We should always subtract the smaller number from the larger number.
Oh, I see. Then that means that the length of MP is the difference between the y-coordinates of M and P, and we get the absolute value of MP is equal to y minus y sub 1.
Yes, that's right. Now let's go back to the two equations we have on the board. Can anyone tell me how we can get the value of x?
Since AP and MR are congruent, their lengths are equal. Can I solve for x on the board, Miss Michelle?
Yes, sure. Go ahead, Dancel.
The absolute value of AP is equal to the absolute value of MR. Then we get x minus x sub 1 is equal to x sub 2 minus x. Then we get 2x is equal to x sub 1 plus x sub 2. We get the sum of x sub 1 and x sub 2 and divide this by 2.
How about the value of y?
I think we can use the other pair of congruent sides, MP and BR.
Would you like to show how to solve for the value of y?
Okay, I'll do it. The absolute value of MP is equal to the absolute value of BR. So y minus y sub 1 is equal to y sub 2 minus y. Then 2y is equal to y sub 1 plus y sub 2. Y is the average of the values of y sub 1 and y sub 2.
Very good. You have just derived the formula for the coordinates of the midpoint of a line segment when the coordinates of the endpoints are given. We call this the midpoint formula. Now let's apply the formula to the following problem. How do we apply the midpoint formula to this problem?
The diameter always passes through the center and is twice as long as the radius. Hence, the center is the midpoint of the diameter.
Very good. Would you like to solve the problem, Dancel?
Okay.
Would you like to explain your work?
Alright. We know that all diameters pass through the center, and each half of the diameter is a radius. This shows that the center is the midpoint of every diameter. So since we are given the endpoints of a diameter, we can get the center using the midpoint formula.
Very good, Dancel. Now let's consider another problem.
Can I try it, Miss Michelle?
Go ahead.
We substitute the coordinates of A and M into the midpoint formula and solve for the coordinates of B.